So what is this? Okay, ignore the English, you read it in your spare time. So the idea is, I have a straight line. I'm saying this circle and this straight line have the same number of points. And here's the funny part, this straight line can go to forever. The idea is give me a f that is bijective function. This f is called stereographic projection. It's saying that I map this black line on this circle by a method that looks like this. I stand here, okay, this is me. I stand on this black dot. You can think of it as North Pole. And then I just take binoculars and then put a straight line to the point I want to see. Let's say cross this. Then this line is mapping this particular dot on this circle to this dot. So these two dots are mapped. Let me draw a better color. So this dot is mapped to this dot. What happens if I view a little bit higher? If I view a little bit higher, then I will shoot a line that looks like this. Then I have mapped this dot to this dot. Okay, not this dot. I mean, it should be this dot. Well, these two lines are the same line. I just have bad drawing. What about this dot? Well, I have another line. So you can imagine, I have a bunch of lines here. If I keep doing this, basically I cover everything in this arc, right? And I do the same thing for all the other side. Then I have a way to map all the points on a circle to a line. Then that means what? I know the size of the circle is the same as the size of the line. And then here's another one. Two concentric circles with different radius have the same number of points. Okay, this is my circle one with a small radius. And I have a big circle here. This is another circle with longer radius. They have the same number of points. Why? Because I can stand here and then I look into this direction. This looking give me these 2 points. This 2 point is a 1-1 correspondent. And then I look here. This 2 point is a 1-1 correspondent. I just turn around 360 degrees. Then everything between a point on the small circle and a point on the big circle, they have a 1-1 correspondent. Then these two sets have the same number of elements. So that means I have C1, circle 1 equal to the cardinality of C2. Just to remind you, two sets equal in cardinality do not mean they are the same thing. I have a set, this set is your father. I assume you have one father. So they have the same number of cardinality. Does that mean I'm your father? No. Cardinality and the content inside are totally two different things. Okay, so we are just saying that we can build a 1-1 correspondence between them.